All right, welcome to day one of Advent of Code. As you can see, it's December 25th, and the contest has just finished today. I have completed the contest. You can see I have 50 stars. I've done all my days. But I did them in Python, and Python is a language that I work with quite a bit in a lot of different areas and for a bunch of different purposes. But I want to use this chance to teach myself or become more familiar with languages that I don't use as much. And so I'm recording this series in C++. My goal is for this to be educational. I do want people to be able to like look at the videos and hopefully take something away from them. But I also hope that this is an opportunity for me to learn. I learn really well by teaching or by explaining stuff out loud. And I think hopefully if enough people see this, maybe there could be like a comment section active with suggestions and everything. I know in my solution for today, there's something, or I use a block of code that I'm certain can be improved. And so, getting feedback on things like that is also, I'm hoping that I can get something out of doing this as well. But yeah, so without further ado, let's get into day one. Day one, pretty straightforward. Part two, there's an interesting opportunity to use a pretty universal and useful algorithm. But part one of day one is very straightforward. So I usually skip over some of the lore reading and I just try to read the problem. So they usually give some test input, and then as you can see, I've completed this, so my input will be down here. But anyways, so just reading through this, so we're looking for or each line is a calibration value, or contains a calibration value rather, and the calibration value can be found by combining the first digit and the last digit in that order to form a single two-digit number. So for example, in our input here on line 1, the calibration value would be 12 because it's you combine 1 and 2 and then parse that as an integer. For line 2, it would be 38. For line 3, it's a little bit more interesting because you have 1, 2, 3, 4, 5, but you just would take the 1 and the 5 to get 15. And then it's simply just asking you to sum these values. Notice on line 4, however, there's only one digit, and so if you run into a case like that, it's asking us to duplicate that digit and read it as like a multiple of 11, basically. So yeah, again, it's asking what the sum is across all calibration values. So let's just head over to VS Code and get right into it. I'm just going to run my little script here to make a new day. And if this is something that you want to like have, I can also put that on my GitHub. But it just generates some like C++ files or just like starter code, so I can time the execution and everything. But I find this to be pretty helpful. So anyways, it parses the input as a series of, or just, I guess, it gives it to me as a vector of strings or an array of strings. And so we can just kind of see what we're working with, I guess. So if we go for int I equals 0, I is less than, let's see, input dot size, I plus plus, we can just, stdc out our input at I and look at what we're getting. And so I'll come in here, day one, and I will run my little script, which I think is p, or no, it's p1.cpp, and then we'll do /p1 test. Okay, perfect. So just a little sanity check here. This is the input that we're getting, and it looks like that's all correct, right? Sweet. So we can get rid of this. I'll keep the for loop, but we'll get rid of the printing, or logging, I should say. And so the idea here is that basically we want to iterate through each line, and then every time we encounter a digit, we will store that, and then we'll simply take the first and the last digits that we encounter for every line, and then add that to our running total ants. And so in order to do that, I am going to initialize a string called digits. It'll just be empty to begin. And then I'm going to iterate through the line. So I will call this j. Well, let's be a little more specific. I'll call it character index, which will start at 0, and it will go to the size of the line that we're on, and that we want to increment it by 1. And then, so in order to check whether we encounter a digit, C++ has a function called isDigit out of the standard library. Well, actually, for isDigit, you do need to include this CC type library. I recommend just including all these libraries. They'll come in very, very useful in the future. So anyways, isDigit, and then we just pass in the character we'd like to evaluate. So that will be the character at input line I at index char idx. And then, so if this expression evaluates to true, we want to concatenate that character into our digit string. Okay, and then can't forget the semicolon. And then, so this will take care of generating our digit string for a single line. And then we need to decide which ones we want to keep, which digits we want to keep. So I will initialize another string called keep, and then the way that we'll do this is we first need to check if we only have one digit. If we only have one digit, we need to duplicate it. And so what we'll do is we'll do kept equals digits, or sorry, I called it keep equals digits plus digits. And again, this is because if we go to else, that means we have only one digit. And so, for example, this might be like 1 plus 1, which will evaluate to 11, right? Okay, but if we have multiple digits, we want to take the first digit, which will be the substring starting at index 0 and of length 1, plus the substring starting at digits.size -1, so the very last index, and also that will be of length 1. And then finally, we can add the kept digit. So now keep is basically our 2-digit number that we want to add to our running total. So we'll parse it as an integer, which the way you do that is the s2i function. We'll parse keep, and then that should be our answer. And then my code will handle outputting everything. So I'm going to recompile, and then I will run it on the test input, and it looks like we get 142, and that is correct. And so just to run it on the real input, we get 54,632, which is correct. Awesome. So now moving on to part 2. Oh, by the way, if you're doing this just for the first time, your input will be different than mine. So your test input or your test output should be the same, but your answer should be different. I mean, generally they're within the same range of each other. So like, let's say you get 500,000, likely you did something incorrect, but anywhere reasonably in this range should be correct. But if for some reason my code doesn't work for your input, please let me know. Anyways, part 2, slightly more involved. And now in Python, this is actually, part 2 is quite easy. So what it wants you to do is it's now replacing some of the numerical digits with like alphabets, or excuse me, with characters or words that correspond to these digits, or alphabetic digits, I should say. And so we want to parse 2 as the number 2. And so this is the way that I approached this was a sliding window problem. And so the sliding window algorithm is very, very useful. It comes up a lot in interviews and many different use cases. So the way that I applied it in this case was we start with t. We start by looking at t, and then we're going to expand this window. So then we'll expand our window to tw, and we'll ask ourselves, is this a valid word? And then we'll obviously answer no, because tw is not a word. TWO, however, is. And so TWO is a valid word that corresponds to a number we're looking for. And so we'll stop the window here and we'll take 2 and we'll store that somewhere. The nice thing about this is that all of the digits have to be single digits. So like 16 would not be parsed as 16. It would actually just be parsed as 6, and then the teen would be ignored, which makes things much easier. So back to this example, after we identify the 2, we'll then move to the W, and our window will contain only the W. We'll evaluate the W. If it's a word, or if it's valid, we will keep it, but clearly W by itself is not valid. So then we'll go WO, which is also not valid, WO1, still not valid, all the way to the end. And we'll see that nothing that starts with a W here is valid. And we'll repeat that for every character. And so this, in the worst case, I believe has, I think, O of n squared time complexity, where n is the number of characters in the string, or it trends toward n squared. I think its upper bound is n squared, because you can imagine that, well, yeah, again, in the worst case, I do think it is n squared, especially if you do check backward. But on average, it evaluates to be a little bit faster. And if you look at the input, like, none of our strings are that long, so really it's not too bad to use the sliding window algorithm. So with that, what we're going to do is we will come back into the code and then open up part2.cpp, and then we'll begin our solution here. So the first thing that we need to do is ask ourselves which characters are actually valid, or excuse me, which words are valid. And when I started the video, I said that I used a block of code here that I have a feeling can be drastically improved. And so I think my general approach is correct, because we should be using a map here, or a hash map. So we want to map from a string to an integer. And so I call this window map. And the way that I populated it is the questionable thing. So I literally just had, I just wrote every single character that we could encounter, or a word. So 1, 2, 3, and so on, and the same thing for the characters. 1, 2, 3, 4, 5, all the way through to 9. There's probably a better way to do that, but honestly, I think it's fine for now, especially on day 1. And so now that we have our map, a way to convert words that we encounter, or basically this is a way to check if a word we encounter is valid. We're going to iterate through the test cases, or excuse me, iterate through the lines of input. So just like before, we'll do for int I equals 0, I is less than the size of the input, where input again is a vector of strings, where each string is a line. We will, so here this outer loop iterates through all the test cases, or yeah, lines, I suppose. And then for each line, we want to store a vector of integers called found digits. And found digits is going to contain every single number which we encounter. And we'll basically do the same thing that we did for part 1, where we take the first and last element of found digits and parse them as a 2-digit integer. So now we can begin the sliding window. So for the window start, which will start at 0, and window start will go to the size of the current line, and it will be incremented by 1. Start plus plus. We want to define a window end, which will begin 1 index after window start. Sorry, that should say window start. And then while window end is less than or equal to the input, or the current line, the size of the current line, we want to basically check whether our current window, which is simply the substring, so input I refers to the current line that we're on, and then we're gonna slice it in the way we slice in C++ is with the substring method, and we pass in the index we'd like to start at, and this is inclusive. Oh, sorry, this should be std string window. We pass in the starting index as well as the length. So you can imagine that the length of the substring that we're interested in is the end index of the window minus the start index of the window. This part tripped me up a bit, especially coming from, or having used JavaScript's substring method. In JavaScript, I'm fairly certain you pass in the start and then the end. Start is inclusive though. But here, again in C++, we're interested in the start and the length. So that's something important to note about the substring method. But moving on, so now that we have our window, we can simply check whether our window is valid. And the way that we do that is we want to use the find method on our map. So we check that our window does not equal the end of the map. And so this syntax, so if you're coming from Python or something similar, or a similar language, this syntax is essentially saying if window in window map.keys, right? So we have a set of keys and a set of values, or I guess the value is not technically a set because there are repeated values, but the keys are a set, and we want to check if within that set this window exists. And so the syntax for doing that in C++ is in fact window or map.find. You pass in what you're looking for and then make sure it does not equal the end of the window. And so if this is the case, that means that we found a valid window. And what we want to do then is we want to append or push the corresponding integer value, or the integer value to which our window corresponds, into our vector called found digits. And so we will simply look up our window in the window map, right? And then we can break out of the while loop and move on to the next window start. Okay. Now, however, if our window is invalid, we need to make sure that we expand our window to keep looking. And the way that we do that is incrementing the end value or end index of our window by 1. Wonderful. So the next thing we'll do is, once we've looped over the entire line, so once we've moved our window across the entire line, we want to find which number we need to add to our running sum. So I'll initialize another vector called final nums. And inside of final nums is where I'm going to put the numbers that I keep. And the way that we identify the numbers that we keep is essentially the same as we did in part 1. So in part 1, we took the first and the last number that we found and parsed them as a 2-digit integer. And then if we only found one number, we parse that as a multiple of 11. And we're going to do the same thing here, except now we're working with a vector and not a string. So if found digits dot size is greater than 1, which means we have found more than one valid digit, we are going to push, so again, if we look here, our found digits are integers. So we can't simply say found digits 0 plus found digits, and this would be found digits dot size minus 1. We can't do this because the values that are stored in found digits are integers. So let's say, for example, found digits at this point is equal to like 1, 2, 3. If we say 1 plus 3, that will evaluate to 4. The reason it didn't in part 1 is because we were working, again, with a string. So what we need to do is we need to just use simple math to parse this to do this operation. So we want 1 and 3 to equal 13. So the way that we'll do that is 1 times 10 plus 3 times 1. And this is very easy to see, I guess. There's like a formula for it, but I assume that you're comfortable with that. So we need to multiply the first value by 10. And then if we only have one digit, what we will do is this same thing, except rather than trying to get the last, well, I suppose this would still work. I don't think we really need if else, actually, now that I'm looking at it, but it just makes it a little more obvious what's happening. And then finally, for every value that we find in final nums, dot size, and then I plus plus, we are going to add that to our answer. So I hope this makes sense. We can see if we do crun. Crun, by the way, I don't think would normally work. It's a custom command that I have in my bin. And so then if we do /p2 test, we can see. So actually, one thing I should point out is that the test input for part 2 is actually different than the test input for part 1. This is not very common, but it does happen on day 1, which is a little interesting. So I'm going to make a new test or a text file called test2.txt and paste my input in there. And then I will do test the sum test 2, and we see the answer is 281. The answer is 281, and so I'll just run it on in real quick, and it looks like we get 54,019, and that is in fact what I got. It's awesome. If you have any questions, please leave them in the comment, and I will be back tomorrow.